Okay. So ultrasonic. So ultrasonic means the name itself indicates ultrasonic. That means here because of the vibration force. Okay. So the metals which are to be welded. Okay. The metals which are to be welded are welding by using the ultrasonic welding. Okay. That means nothing but the vibration force. Okay. The welding equipment consisting of two units. So mainly here for ultrasonic welding, so here it consisting of two units. First one is a power source of frequency converters, which converts 50 cycle line power into high frequency electric power. Okay, so that means, so generally our electrical supply is whenever you have to giving the AC supply, generally supply frequency having the frequency of 50 cycles. That means 50 Hz we are giving. Okay, so that 50 Hz will be converted into high frequency. Okay, so that means that frequency value will be increases. Why? Because ultrasonic welding means is nothing but it is welded the metals by using the vibration force. So whenever you having the more frequency at the time, the vibrational force is also high. So that's why here you have, first of all you have to use the frequency converter. So next one is transducer. The transducer which changes the high frequency electrical power into the electrical energy. Okay, so first the frequency converter will convert the 50 cycle frequency into the high frequency. So next this high frequency will be converted into the vibration energy. Okay, by using the transducer. See, this is the arrangement of the ultrasonic welding. Okay, so this is a frequency converter. Okay, so by using this frequency converter, you can convert the 50 cycle frequency into high frequency, and this will be given to the transducer. Here the transducer will convert this high frequency into the vibrational energy. Okay, see the components to be joined are simply clamped between the welding tip and supporting anvil. See here you have, so this is the supporting tip. So for this tip you have to fix one plate. Anvil is nothing but a one base. On this base you have to place the another plate. So here the two metal plates will be welded by using the ultrasonic welding. Okay. So with just enough pressure to hold them in close contact, the high frequency vibrator energy is then transmitted to the joint for the required period of time. The bonding is accomplished with applying external heat, filler or rod or metal. Okay. See. Here you have to place the two metal plates. Okay, these are the two metal plates which are to be welded. Okay, so here at that time, so whenever by using this frequency converter, here you have to convert the high frequency 50 cycles frequency into the high frequency. That frequency will be given to the here transducer. The transducer will convert that energy into the vibration energy. So through the coupler that vibration energy is given to this plate. Okay, to the pressure, okay, these two metal plates will be welded. Okay, so that means here there is no use of extra heat or arc. Okay, so or any filler material will not be used. Okay, because of only the vibration. Okay, because of the only vibration force, the two metal plates will be welded. So that is nothing but the ultrasonic welding. So here the metal's thickness varies from 0.0425 mm to 0.25 mm. Okay, so here you can take the metal plates which are to be welded having the thickness of 0.000425 to 0.25 mm. So in between these two these range you have to choose the plates. So coming to the uses or applications. Okay, coming to the uses or applications of the ultrasonic welding, joining electrical and electronic components. Okay, so it will join the electrical and electronic components, hermetic sealing of materials and devices. Okay, so to seal any devices, okay, materials, we are using the ultrasonic welding. Splicing metallic foil. Okay, so welding aluminum wire and sheets. Okay, to weld the aluminum wire and sheets also we have to use the ultrasonic welding. Fabricating nuclear fuels. In the fabrication of nuclear fuel elements also we have to use the ultrasonic welding. So up to now here you have to complete the types of welding. Okay, so the welding, okay, the welding is mainly classified into the electric welding is mainly classified into two types. What are those? Resistance welding, electric arc welding. So the resistance welding is again classified into 5 types. What are those? Spot welding, seam welding, projection welding. Okay, so 4 types. Butt welding. Okay, these are the 4 types of weldings. The resistance welding will be classified. So the butt welding is again classified into 3 types. What are those? Upset butt welding, flash butt welding, percussion butt welding. Okay, these are the 3 types of butt welding. So next, electric arc welding. Okay, that means the metal plates here are welded by using the arc. So those are classified into 5 types. What are those? Metal arc welding, okay, arc welding, inert gas arc welding, hydrogen arc welding. Okay, so in previous class we are discussing. So next you can see extra another type is ultrasonic welding. So up to now we are completed the classification of welding. So now here you have to each and every welding here you have to use the electrodes. So in welding process we have to use which types of electrodes. So that is nothing but types of welding electrodes. Okay. See, an electrode is a piece of metal in the form of wire or rod that is either bare or coated uniformly with flex. So here in welding process, here you are using the electrode is a one piece or metal in the form of wire or rod. Okay, it is in the form of a wire or rod that is either bare or coated uniformly with flex. Either that is in the bare, okay, or coating with flex. Okay, so that electrode will be coating with flex. Electrode carries current for the welding operation. Here what is the purpose of this electrodes used in the welding process? Nothing but this carries the current for the welding operation. One contact end of the electrode must be clean and is inserted into the electrode holder. Okay, so in each case you have to see. So compulsory one end of the electrode is compulsory placed inserted into the electron hole and arc is set up at the other end. So at the time the arc will be set up in the other end. So the electrode used for the arc welding are classified as following. See, these are the electrodes. Okay, this is the classification of electrodes. So the electrodes are mainly classified into 2 types. What are those? Consumable electrodes, non-consumable electrodes. Okay, so the electrodes are classified into how many types? 2 types. What are those? Consumable electrodes and non-consumable electrodes. Okay, so the consumable electrodes are again classified into 2 types. What are those? Bare electrodes. Second one is coated electrodes or cured electrodes. Okay, so this coated electrodes is again classified into 2 types. Lightly coated, okay, that means lightly coating with flex, heavily coated, shielded. Okay, so these are the 2 types. So this is non-consumable. So non-consumable is only single one. There is no classification and sub-classification in non-consumable electrodes. So first you have to see what is the consumable electrodes and what is the non-consumable electrodes. So next you have to or discussing all these type of electrodes now. Okay, first of all you have to see non-consumable electrodes. Non-consumable electrodes are nothing but electrodes which do not consume or fuse during the welding process are called non-consumable electrodes. Okay, so that means during the welding process do not consume, okay, or fuse. That means that electrode will not used in that welding process. That means the electrodes are not melted or fused. Okay, so that type of electrodes will be called as the non-consumable electrodes. So examples are electrodes made of carbon, graphite, tungsten do not consume during welding. Okay, so here you have to using the carbon, graphite, tungsten electrodes. So those are comes under the category of non-consumable electrodes. Okay, so next one is what? Consumable electrodes. So the name itself indicates. So non-consumable means you cannot use. Consumable means you can use in the welding process. Okay, so consumable electrodes. Consumable electrodes means electrodes which are consumed during the welding operation are consumable electrodes. Okay, the electrodes which are consumed in the welding process are called as consumable electrodes. These are made up of various materials depending upon their purpose and the chemical compositions of the metal to be welded. Okay, so the consumable electrodes are made with various materials according to the, okay, depending upon the chemical so that means chemical composition of the metals which is to be welded. Okay, so the consumable electrodes are made in the form of rod. Okay, so these are consumable electrodes are made in the form of rod having diameter of about 2 to 8 meters. Okay, so these consumable electrodes having the diameter of 2 to 8 meters and length about 200 to that means diameter, width will be 2 to 8 meters and length will be 200 to 500 millimeters. They act as filler rod and are consumed during the welding process. Okay, so the consumable electrodes are itself act as the filler material for the welding process. Okay, so so consumable electrodes are classified into bare electrodes, coated electrodes. So these coated electrodes are again classified into lightly doped, heavily doped. So first you can see the bare electrodes and coated electrodes. Bare electrodes. These are the consumable electrodes which are not coated with any flexing material. Okay, bare electrodes are nothing but these are the comes under the category of consumable electrodes, but they are not coated with any flexing material. Bare electrodes are in the form of wire. Okay, these are in the form of a wire. During welding operation, an arc struck between the workpiece and the electrode wire, then the electrodes is melted down into the weld. So whenever, so here you have discussing about this. So electrodes are mainly used in the here electric arc welding. So whenever, so you have, so bare electrodes means these are not in the form of rod. So these are only in the form of a wire. So whenever the arc will be struck between the electrode wire and the so at that time the electrode wire will be melted and melting. Okay, and will weld the welding metal. Okay. So when the molten metal electrode and the workpiece are exposed to the atmospheric of oxygen and nitrogen, they form their oxides and nitrogen and cause some non-metallic. See, whenever, so here I am says that here you have to using the bare electrode is wire. So at that time this electrode and workpiece means the metal which is to be welded, that is called, that is you can say that workpiece, that are exposed to the atmospheric oxygen and nitrogen. So at that time, so this total process will be takes place in some atmosphere. So at that time, so they have to expose it to the oxygen and nitrogen present in the atmosphere. At that time they can form oxides and nitrates. Okay, so at that time it reduces the strength and ductility of the deposit weld. So at that time the strength of the weld may be decreases. Okay, so the bare electrodes are usually employed in automatic and semi-automatic welding. Okay, so the electrodes are usually employed in the automatic and semi-automatic welding. With a bare electrode, the welding can be done satisfactorily with DC supply only if the electrode should be connected to the negative terminal of the supply. Okay, so here you can get the satisfactory operation by using the bare electrodes whenever only you have to giving the DC supply to the bare electrode. Okay, and that electrode is also connected to the negative terminal. Okay, so on the other side, for the metal plate, here you have to giving the positive supply. Okay, so in consumable electrodes, so one is bare electrodes, second one is what? Coated electrodes. Okay, coming to the coated electrodes, depending upon thickness of the flex coating. Okay, so that means they are coated with some flex. Okay, any other material flex. Okay, depending upon the thickness of flex coating. Okay, the coated electrodes may be classified into lightly coated electrodes, heavily coated electrodes. Okay, so the name itself indicates these electrodes are coated with thin layer of coating material up to less than 1 mm. Okay, so that means they are lightly coated. Okay, that means they have thin layer of coating material up to only less than 1 mm. 1 mm diameter you have to coating the flex, so that electrodes are called as lightly coated electrodes. This coating is usually consisting of lime mixed with soluble glass which serve as a binder. Okay, see, here you have to use the lime. Okay, so that coating is nothing but lime. Okay, these electrodes are considered as a lime is nothing but you have to know lime. Okay, so these electrodes are considered as improvement over the bare electrodes. Okay, these are considered as the over improvement of bare electrodes. Okay, the main purpose of using the light coating layer on the electrode is to increase the arc stability. Okay, why you are using the coating with the flex means to increasing the arc stability, so they are also called as stabilizing electrodes. So that's why these lightly coated electrodes is also called as stabilizing electrodes. The mechanical strength of the weld increased because sag layer will not formed on the molten weld. Okay, so in previous case, so here in bare electrodes we are forming the oxides and nitrates. So, but here there is no formation of oxide and nitrates. Why? Because to protect, so here you have to protecting the electrode with a flex coating. Okay, so that's why there will be not oxides and nitrates will not be exist. For this reason, lightly coated electrodes may only used for the welding of non-essential workpieces. Okay, so that's why this is only useful for the welding of non-essential workpieces. Okay. Next one is what? Heavily coated electrodes. Okay, these electrodes have a coating layer with heavy thickness. Okay, so the name itself. Okay, these electrodes have coating with heavy thickness. Okay, the heavily coated electrodes sometimes referred to as shielded arc electrodes. Okay, so heavily coated electrodes are also sometimes called as the shielded arc electrodes. Okay, so the materials commonly used for the coating the electrodes. Okay, here to coating the electrodes, you are using the materials are titanium oxide, ferromanganese, silica, fluoroxidase, clay, calcium carbonate, etc. These are the materials are used to coating the electrodes. This electrode coating helps in improving the quality of weld, as if the coating layer of the electrode burns into the heat, the arc provides gaseous shield around the arc, which prevents the formation of oxides and nitrates. Okay. So this whenever we have to using the heavily coated electrodes, okay, this coating will be helps in the improving the quality of the weld. Okay, so as if the coating layer, so whenever arc will be exist, that there will be burns. Okay, at that time this is total surround the arc as a gaseous shield. Okay, shield means to protect the arc to perform the from the formation of oxides and nitrates. So up to this we have to completed the what are the different types of electrodes are used in the welding process. So next we have to see the comparison between resistance welding and arc welding. Resistance welding, the source of supply is only AC. So here you have to giving the only AC supply. So for arc welding, either you have to giving the AC supply or DC supply. Okay, and again in the AC supply, either you have to giving the single phase AC or three-phase AC supply. The head developed is mainly due to the flow of contact resistance. Okay, so here the heat, okay, the heat develops only due to the contact resistance, but here the heat developed mainly due to the striking the arc between two electrodes. Okay, or an electrode and workpiece. So either between two electrodes, or the second one is either our electrode and workpiece. The temperature attained by the workpieces is not so high. Here the temperature is not high, but here the temperature of the arc is so high, so proper care should be taken during the welding. So here the welding is done only the arc, so that's why here the temperature will be also very high. So at that time during the welding process, we have to take the care. Here external pressure is required in resistance welding. No external pressure is required, hence the welding equipment is more simple and easy to control. Okay, so the resistance welding requires external pressure, but the arc welding do not use the external pressure. Why? Because here the welding equipment is more simple and easy to control. Okay, filler metal is not required to join the two metal pieces. So here there is no use of filler metal in the resistance welding, but suitable filler electrodes are necessary to get the proper welding strength. Okay, so arc welding will be used as the filler materials. It cannot be used for repair work. It is suitable for mass production. So it is not used for repair. So in any case, some maybe metals are repaired. So for repair purpose, it will be not uses. So it is not suitable for mass production. It is more suitable for repair work. Okay, so it is only more suitable for the repair work. Here in resistance welding, the power consumption is low, but in arc welding, the power consumption is high. Okay, so these are the comparisons between the resistance welding and arc welding. So defects in welding. When you have to say that welding will be defected. Okay. So see, a weld not properly welded is a defective weld. Okay. Defective welding is nothing but whenever you have to do the proper welding, do not. So at that time you can say that there is a defective welding. A properly made weld should have the following characteristics. So if suppose you have to do proper in welding. So at that time this have must and should be carried. The weld should not crack in the bend test. So at bends, okay, at bends, so the weld not be cracked. It should not contain scum or slag embedded in the weld. Okay, so there will be no slag. Slag is nothing but up and downs. Okay. Next one is appearance should be ripple like and not spongy. Okay, so it is like a ripple shape and not spongy. Okay, it is a will be strong. It should not have cavities and the grain size should be uniform. So there will be no cavities. Okay, so and size should be also uniform. Over current tries to dissolve scum in the weld, while under current tries to give the cracks in the weld. If suppose over currents will be occur, so at the time some cracks may be occurs in the welding. If electrode distance from the weld is varying, this will cause the unevenness of the weld. Okay, so whenever you have to increase the distance from the metal plate, that means the metal plate which is to be welded, so at that time it will be cause the maybe unevenness in the welding process. Okay, these are the defects in the welding. So up to now you have to complete the welding. Okay, so what is the electric welding? Okay, so why you are using the electric welding? What are the advantages and disadvantages? And I have to see the different types of weldings and what are the electrodes used in the welding process. So up to now here you have to complete the electric welding. So next one, last topic is electrolysis. Okay, so all of you well know about electrolysis. In previous classes, that means in intermediate and something, we have to study it in chemistry. Okay, electrolysis. So the term electrolysis was first popularized in the 19th century. Okay, so it is popularized in the 19th century by the Michael Faraday. Okay, so the electrolysis process was introduced in the 19th century by the Michael Faraday. It was a process that helped in the study of chemical reactions in obtaining the pure elements. Okay, so this process will be helps in the study of chemical reactions. Okay, in the study of chemical reactions. Okay, in obtaining the pure elements. Okay, today this process is commercially important as it is uses widely in separating or obtaining pure elements from naturally occurring sources such as ores. So to separate the metals or any materials from their ores. Okay, so ores. So you will have to using the electrolysis process. Electrolysis refers to the decomposition of a substance by an electric current. Okay, so decomposition of a substance by an electrical current is nothing but the electrolysis. Electrolyte. See, an electrolyte is a chemical that atoms are normally closely bonded together, but when it is dissolved in water, its molecules split into positive and negative ions. So generally, the atoms are chemically bonded. But whenever that atom will be dissolved in water, so at that time they will be split into positive and negative ions. The positively charged ions are referred to as cations, whereas negatively charged ions are referred to as cations, and negatively charged ions referred as anions. Okay, both cations and anions move freely in the solutions. Okay, see, principle of electrolysis. Okay. So, as discussed in the definition of electrolyte, whenever an electrolyte gets dissolved in water, so whenever any electrolyte will be gets dissolved in water, its molecules split into cations and anions, moving freely in the electrolytic solution. Okay, now two metal rods are immersed in the solution. So, whenever there are cations and anions freely immersed in the solution, moving in the solution, at that time in that solution you have to immerse the rods. Metal rods are nothing but electrolytes. Okay, so now two metal rods are immersed in the solution. So and an electrical potential difference applied between the rods. So at that time you have to giving the supply to the two rods externally, preferably by a battery. Okay, by using the battery voltage. Okay, so here you have to giving the supply to the rods. These partly immersed rods are technically referred as electrodes. Okay, in our technical points, those rods are called electrodes. The electrode connected with negative terminal of the battery is known as cathode. Okay, so the electrode which is given to the negative supply of the battery, that is called cathode, and the electrode connected with the positive terminal of the battery is known as anode. Okay, the freely movingly positively charged cations are attracted by the cathode. So cations means there is having the positively charged, these are attracted by the cathode, and negatively charged anions are attracted by the anode. In cathode, the positive cations takes electrons from the negative cathode, and in anode, negative ions gives electrons to the positive anode. For continuously taking and giving electrons in cathode and anode respectively, there must be flow of electrons in the external circuit of the electrolytic. So at that time, there will be electrons will be flows through the external circuit. That means current continue to circulate around the closed loop created by the battery. So at that time, for taking and giving the electrons is nothing but flow of charge will flow through that solution. So at the time the electrical current will flow through the solution. So this is the most basic principle of the electrolysis. Okay. So suppose here you have to take the copper sulfate solution. So whenever copper sulfate or CuSO4 is added to the water, so it is added to the water, it gets dissolved into the water. As CaSO4 is an electrolyte, split into Cu++ and SO4 minus. Okay, that means cations, anions, and move freely in the solution. Now, if two copper electrodes immersed in the solution, at that time you have to see here. This is copper sulfate solution. Okay, in this sulfation, here you have to take the two electrodes. This is the anode, this is the cathode. Okay, so this copper sulfate solution will be split into the cation Cu++ and anions SO4 minus minus. So at the time SO4 minus minus moves towards the anode and Cu++ moves towards the cathode. Okay. And reaching on the cathode, Cu+ take the electrons from it, becomes a neutral copper atoms. So see, and whenever the Cu++ goes near to the cathode, so at that time they can collect the electrons from the cathode. Why? Because the cathode is connected to the negative terminal of the battery. So at that time this having the high capacity of the electrons. So at that time they can collect the electrons from the cathode and they will become a neutral atom. So similarly here anode. So for anode it will gives the takes so the SO4 minus minus will comes close near to the anode. So at that time the anode having positive charge and it will use the anions to the SO4 minus minus. So at that time they will becomes the neutral anions. So see, SO4 ions will move towards the anode where they give up the two electrons and becomes SO4 radical. But since SO4 radical cannot exist in the electrical neutral state, it will attack the copper anode and will form the copper sulfate. So whenever these are moving towards these sulfate ions moving towards this copper electrode, so at that time they can form the copper sulfate. If during electrolysis of copper sulfate, you can use the carbon electrode instead of copper or other metal electrodes, the electrolysis reaction will be little bit different. Actually, SO4 cannot react with carbon, and in this case, SO4 will react with water of the solution and will form the sulfuric and oxygen. See, here this SO4 will be a contact with this water. Okay, so and it will forms the H2SO4 and O2. That means again, so here already you have to using the solution is copper sulfate, but it is produced as the sulfuric acid. So and liberate the oxygen. Okay, so the process described above is known as electrolysis. Okay, in the above process, after taking the electrons, the neutral copper atoms get deposited on the cathode. At the same time, SO4 that means here this is formed whenever this will be. See, whenever the SO4 goes to the anode, at the time they can form the copper sulfate. That means again the copper sulfate solution will be formed in the container. Okay, that means recycle the process. Okay, at the same time SO4 reacts with the copper anode and becomes but in water cannot exist single molecule, instead of it is split into Cu++ and SO4 minus and dissolved in water. Again this will be dissolved in the water as Cu++ and SO4 minus. So it can be concluded that during the electrolysis of copper sulfate with copper electrodes, copper is deposited on the cathode, copper is removed from the anode and the same amount. Okay, so and here the electrolysis process is explained by using the Faraday's laws. Okay, here they are using the two Faraday's laws to explain the electrolysis process. So what are those? Means Faraday's first law of electrolysis and next one is Faraday's second law of electrolysis. So first here you have to see the Faraday's first law of electrolysis. It states that the mass of a substance liberated from an electrolyte in a given time proportional to the quantity of electricity passing through the electrolyte. Okay, so here in electrolysis process the substance will be liberated from an electrolyte. Okay, so see here the copper sulfate is liberated from the substance. So at that time similarly, so the Faraday's first law is nothing but it states that the mass of the substance liberated from an electrolyte in a given time. is proportional to the quantity or electricity passing through the electrolyte. So is directly proportional to the electricity passing through that electrolyte. According to this law, the chemical deposition due to flow of current through the electrolyte is directly proportional to the quantity of electrode passed, that is the mass of chemical, where Z is the constant proportionality and is known as the electrochemical equivalent of the substance. If you coulombs in okay, so in next class I will see here. This is the Q, M equal mass is directly proportional to Q. Whenever you have to remove the proportionality constant, so that means M is directly proportional to the quantity of electricity. So whenever you have to remove the proportionality, at that time you can mention M equal to ZQ. Here Z is nothing but chemical equivalent. See here you can assume Z is constant of as a chemical equivalent of the substance. If you put Q equal to 1 coulombs in the above equation, we will get Z equal to M. So if suppose you can mention Q equal to 1, so at that time that is equal to M is equal to Z. So that means which implies that electrochemical equivalent of any substance is the amount of substance deposited. Okay, so at that time it is defined as the electrochemical equivalent. Okay, is equal to the substance, the amount of the substance deposited. Okay. So that means 1 coulomb of electrical current passing through the solution. Okay, whenever Q means 1. So whenever you have to take the 1 means 1 coulomb of electrical current passing through the solution. So at that time the electrochemical equivalent is equal to the mass of the substance deposited. Okay, this constant of passing the electrochemical equivalent is generally expressed in terms of milligram per coulomb. Okay, so this electrochemical equivalent is generally expressed in milligram per coulomb or kilogram per coulomb. Okay, so here Q means charge. Charge formula is current and time. Q equal to IT. You can also express here. So at that time what the formula will become M equal to ZIT. So that means in place of Q here you can write the IT. So I equal to the steady current in amperes. T equal to time per which current will flow through the electrolyte. Okay, this is the Faraday's first law. So next one is what? Faraday's second law of electrolysis. Okay. So see, the Faraday's second law of electrolysis states that when the same quantity of electricity is passed to the several electrolytes. So if suppose you have to take 10 amperes, so if 10 amperes will pass to the different several electrolytes, the masses of the substance deposited are proportional to the respective chemical equivalents. So in each case, the mass of the substance deposited, okay, that how much amount of the mass of the substance is deposited is proportional to the chemical equivalence. Okay, so that means Z. Okay, so in other way, so another statement for the Faraday's second law is nothing but Faraday's second law of electrolysis states that when the same quantity of electricity passes through the several equivalents, okay, the mass of the substance deposited are respect to the same definition. Okay, so chemical equivalent, I will say that here. So what is, first of all, what is chemical equivalent or equivalent weight? See, the chemical equivalent Z or equivalent weight of the substance can be determined by the Faraday's law of electrolysis and is defined as the weight of that substance which will combine with or displace unit of hydrogen. The chemical equivalent of the substance is defined as it is ratio of the atomic weight to its valency electrons. See, chemical equivalent is nothing but atomic weight by valency. So if you take different elements having different atomic weights, chemical equivalents. Okay, at that time, why? Because different elements having different atomic weights and valencies. Next, so these are the two laws of Faraday's law of electrolysis. So next one is terms connected with electrolytic process. Okay, what are the terms used in electrolysis process? Are current efficiency, voltage, energy efficiency. So first, current efficiency. So what is the current efficiency? Means nothing but, see, the actual quantity of substance liberated or deposited to the theoretical quantity of substance liberated or deposited. So theoretically first you have to doing, so at the time you have to get one value, but practically when you have to do the experiment, so at the time, so you have not get exactly the theoretical value of amount of metal will not be deposited or liberated. Okay, some amount maybe decreases or increases. Okay, that ratio will be called as current efficiency. See here, the current efficiency is defined as the ratio of actual quantity of substance liberated or deposited to the theoretical quantity as calculated from Faraday's law. Okay, so the value of current efficiency lies between 90 to 98%. Okay, so always the value of current efficiency will be lies in between 90 to 98%. In certain cases, the efficiency will be very low. So for example, in chromium plating, whenever you have to using the chromium plating, so at that time efficiency will be 12 to 15% approximately. Next, second one is what? Voltage. Okay, the voltage that is essentially required to pass the current through the electrolyte depends upon the potential drops, the electrodes in the electrolytes. Okay, potential drops. Okay, so the voltage. Okay, so the voltage required for the electrolysis process will be depending upon the electrodes. That means potential drops across the electrode and the electrolyte. Therefore, it is desirable that these drops are made as small possible. Okay, this can be achieved in many cases by adding special conducting agents to the electrolyte to make it electrolyte a good conductor. For example, dilute sulfuric acid is added to copper sulfate bath in copper plating. Okay, so in some cases the voltage drop may be occur. So at that time that deposited may be distorted. So for that purpose, here some cases you have to add some special conducting agents. Like, okay, so if suppose in the formation of for a dilute sulfuric acid is added to the copper sulfate bath in copper plating. In copper plating, for copper sulfate bath, you have to add the dilute sulfuric acid. So the normal voltage required to pass the current through the most electrolyte is 1 to 2 volts. Okay, so here the voltage required to pass the electrical current through the electrolyte is normally 1 to 2 volts. Next, finally, last one is what? Energy efficiency. Okay, going to secondary reactions, the voltage actually required for the deposition or liberation method is higher than the theoretical value, which increases the actual energy required. Okay, so generally you have to, whenever you have to do the theoretical calculations by using the Faraday's law, so at that time you can get the one energy value, but practically it requires the higher voltage values compared to the theoretical values. That ratio will be called as the energy efficiency. Energy efficiency is defined as the ratio of theoretical deposition of metal. Okay, so that is nothing but the efficiency. These are the three terms used in the electrolytic process. What are those? Current efficiency, voltage, energy efficiency. So next one, applications of electrolysis process. This is very important. See, the major applications of electrolysis are under. So the electrolysis are mainly used in the electro deposition. Electro, that means to deposit the any metal. See, if suppose in electro deposition, again it is used in these six process. What are those? Electroplating, electro deposition, electrometallization, electroflacing, electroforming, electrotyping, and electrorefining. Okay, in these all process you have to use the electrolysis. That means electroplating means you have to coating it any metal. So in that cases you have to use the process is nothing but the electro deposition. Okay, so in that electro deposition you have to use the electrolysis. Manufacturing of chemicals. So in the process of manufacturing of the chemicals also you have to use the electrolysis. Anodizing process, electropolishing. Okay, polishing the metals, electro cleaning and pickling, electro potting or electro stripping, electrometallurgy, electro extraction, and electro refining. Electro extraction is nothing but to obtain the metal from their ores to extract that part. Okay, so in electro refining process, so any impurities are present in that material. So at that time to clean that impurities, we have to also use the electrolysis. Okay, these are the applications of electrolysis process. Okay, so next one is factors affecting the electrolysis process. Okay, so the factors that may affect the electrolysis are the nature of the electrode. So first one, you have to choose the electrodes. Okay, so first the electrolysis process depending upon that nature of that electrode, nature and state of the electrolyte. Okay, and you have to use the container, you have to use the electrolyte. Okay, so and this electrolysis process will be affected by that nature and state of the electrolyte also. So next one is nature and electrode potential of ions present in the electrolyte. Okay, so similarly and depending it is will be also affected by the electrode potential, okay, and ions present in the electrolyte. So next one is over voltages at the electrodes. Okay, so in some cases maybe over voltages occurs at the electrodes. Okay, so this over voltage may be also affect the electrolysis process. And last final one is nothing but power supply for electrolytic process. Okay, to do the power supply, how much amount of energy will be, voltage will be used. See, for electrolytic process, the power supply required is DC. Okay, so generally we are most using the DC supply for the electrolytic process and at very low voltage. Okay, so and that voltage will be also very low. See, the power required for the electrode deposition is usually very small, between 100 and 200 amperes. So the electrode deposition is nothing but it is the application of the electrolytic process. Okay, so whenever you have to electrolysis process is used in the electrode deposition, at that time it uses a very small currents of 10 and to 200 amp, sorry 100 to 200 amperes at voltages 10 to 12 volts. 10 volts or 12 volts. Okay. Okay, so in that case, this is uses a DC generator. Okay, so that is standard induction motor driving a heavy current low voltage DC generator, or preferably here you have to use a separately excited generator. Okay, or by applying the copper oxide rectifier. So either are using the copper oxide rectifier to get the DC voltage. Okay. Why you are using the copper oxide rectifier means it having high operating efficiency and occupies less space and maintenance cost is also low. Next is for extraction and so it is electrolysis process is also used in the extraction and refining of the metals also. So in for extraction and refining metals and large scale manufacture of chemicals, a very large amount of power is required. So in that cases you have to use the power is very large. Since most of the process are continuous, such have 100% load factor, these plants are located near hydroelectric power station or atomic power, even if extra transformer is necessitated. So very large. So these are very large amount of power is required. So that's why these type of plants are located near the hydroelectric power station. That means near the power stations. Okay. So this is the power supply about the electrolytic process. So in this class we are up to now in this class you have to completed the second unit. Okay, so what is the electrolysis? So those all are discussed in this class.